Welcome back. It's time for our fifth and final video from Unit 4. We still haven't gotten to divide, so I sure hope there's some divide stuff in this video. So with no further ado, let's head out to the PowerPoint and see what kind of trouble we can get into. Looks like estimations on the horizon. From the current slide. Come on. There we go. Okay. So now again, the idea isn't what's the exact answer, is to get a ballpark. So what are you going to do on front end? Well, you see that 400, don't you? Yeah, that first 4 is 400. So 400 times 4, get us 1600. 58's kind of clunky, but it's dang close to 60. So we could take 60 times 4, get a decent approximation. Remember, on estimation, it's a convenient number that we seek, not necessarily the exact number that we seek. So an estimate for this would be 1600 plus 240, 1840. That's pretty cool. Oh, I like the purple. Nice. All right, so front end estimation as a means to estimate the answer to 458 times 4. Oh, will you look at that? We just got to the breakout spot for assignment 4A. Problems from your book. Crunch, crunch, crunch. Okay, you can do them. Send me some PDFs back to the box, and I'll get busy grading those. We're going to continue the video, though. So here we go. Oh, look, it's section 5. We're going to divide. I knew it was going to happen. All right, here's your overview slide. These specials dividing by 0 and 1 are problematic. We'll get to that shortly. So we can do sets, we can partition sets, we can do a missing factor, we can do a repeated subtraction. So these are models that you and I will showcase that could be used to represent the idea of dividing. All right, so let's do the old set part. All right, you ready? So you got 10 Snickers bars, and somehow you've decided to share them with groups of 5 students, and you want to know how many each person will get. So here it comes visually, baby. There are the 10 Snickers bars. There are the partitions, and you guessed that each kid's going to get 2 Snickers bars in his or her partition. So that's the partition model. It's pretty clean. I like it a lot. It's harder with remainder. You know, we didn't have 10 Snickers bars. We'd have to convince kids that there were some that didn't get divvied evenly. So it introduces the idea of remainder as well. Missing factor basically takes the notion of dividing and resets it so that you think in terms of multiplication. Again, I think that's useful because I think for kids to know that multiplication and division are inverse operations of one another, it's a good thing. So you're saying, I'm going to take 4 times some number to get 28. What must the number be? Well, obviously the answer is going to have to be 7. So what we just did was 4 times 7 to get the 28, which correlates to 28 divided by 4 to get us the 7. Fancy math words. When you divide, you find the dividend. All right, the guy you're dividing by, in this case, B, is the divisor. The answer would be the quotient. All right, here comes repeated subtraction. In this PowerPoint, I realized I got a real thing with candy. We're gonna bag up some Tootsie Pops, I think. Or no, Tootsie Rolls, my side. So we got 120 Tootsie Rolls, and we've been tasked with putting them in bags of 24 each. So, you know, you got your Tootsie Rolls laying out on the desk, and you got your little plastic bags. So the kicker is, how many bags of Tootsie Rolls could you get, and would you have any left over? So on the next slide, you kind of see it looking like this. You had it 120, so you grabbed the first 24, you put them in a bag. That left you 96 more to bag up. You took another 24 and you put them in a bag. That left you 72 to bag up. And you continue on down and you bag up as many 24s as you can. And you'll see at the bottom of that stack, there were in fact 24 left to bag, and you bagged them. And you guessed it, we got 5 bags of 24. So whether or not you realize it, we just did the math problem 120 divided by 24. How cool was that? So repeated subtraction as a process to replicate the notions of division. Again, I like it. I don't think I would do it where you had gigantic numbers. I think this was a pretty good example for kids to see. Again, for elementary kids, you can actually do this as a hands-on activity. Back in the day, we actually could be able to eat the Tootsie Rolls. Now you'd probably have to do something like Brussels sprouts. All right, kind of in a similar fashion, we're going to bust out our base 10 blocks. So we have 726. So we have 7 flats, We got 2 sticks. We got 6 singles. The question says, can you show me groups of 6? Well, sure, I can show you a group of 6 on the flats. So in fact, that's what you would do. You would be able to get one group of 6 on the flats. Look at that. Almost like I knew what I was talking about. So now the question is, can you show me groups of 6 as it relates to the sticks? This guy calls them longs. Well, you first of all have to take that extra flat and trade him out for sticks. So we'll trade that remaining flat and we'll get, you guessed it, 10 sticks. And now remember, we're grouping in sets of 6. So the question now says, if you take those 12 sticks and we want to group them in sets of 6, we could in fact get 2 sets of 6, as you now see indicated with the little groupings. And then I say, well, geez, I got those singles out there. You guessed it. I can get 1 set of 6. So in this case, the division was by 6. We kept trying to form sets of 6. And our original division set was 726 divided into sets of 6, if you will. We got 1 set of flats, 2 sets of sticks, and 1 set of singles. So we get the answer of 121. All right, we've already kind of talked about inverse operations, and the fact of the matter is that we don't want kids bogged down into failing to appreciate that multiplying and division have something in common, right? One undoes the other. Same thing with adding and subtracting. So those are worthwhile things for us to get kids in on, all right? Dividing by 0 is problematic. We can't do it. Doesn't matter how much math you study, we cannot divide by 0. It will always be undefined. Dividing by 1, however, is easy. Any number divided by 1 is that number itself. When you were in high school, you definitely had teachers who said, let's do order of operations. And you probably heard the phrase PEMDAS. I'm fascinated by the number of kids who have the please excuse my dear Aunt Sally. Obviously, in an elementary setting, I don't think you'll do a lot of exponents. So maybe that just reduces to PMDAS. You can kind of get the exponent out of there. So if they're groupings, they're done first. Multiplies and divides are done on the same level of priority. Got to be careful. That process never says that you must multiply before you divide. I've had this discussion with way many kids. You do them in order. So if you happen to meet a divide before a multiply, you actually do the divide first. And then the last and lowest level of priorities is adds and subtracts. And again, same line there. You may in fact get to subtract before you get to add if the subtraction is encountered before the addition. So I set up some problems for us to practice. Here's our first one. There are no groups. So you're already looking at multiplies and divides as your first levels. So what you see first as you crunch your eyeballs from left to right is you see a 12 divided by 4. And you actually see that before you see the 2 times 3. So you guessed it, my friends. Well, that's pretty cool. That gets done first. All right, so I go ahead and I did 12 divided by 4, and that's how the 3 got there. All right, next, there is a multiply, so it's got to be next. So there's your next challenge, 2 times 3 for 6. And now you're down to just adds and subtracts, again, in order from left to right. So 7 minus 3 is first. That'll get you 4. Then we'll get to add. That'll get you 10. And then last but not least, we'll do 10 minus 4. The answer to our first example looks like 6. So again, be careful. Just because you're used to PEMDAS and my dear Aunt Sally, don't fall into the trap. You may, in fact, have to divide before you multiply. You may, in fact, have to subtract before you add. All right. Second, this one's got a group. So groups go first. So your first set of knowledge here is the 12 minus 5. That'll get you 7. So now look at that and you say, oh man, I got some multiply in there. I got some divides in there. All right, so we're at the multiply divide line. Remember, these guys are done in order from left to right. So that guy's first. He's the first encounter. So 7 divided by 7 gets you a 1. Looks like that 2 times 8 better be next. That'll get you a 16. Now it looks like the last divide is now in play. 16 divided by 4 takes us to 1 plus 4 plus 2. There's an add for 5. our last add for 7. Okay, parentheses were first. Then we defaulted to multiplies and divides in order from left to right. So again, we did have to divide before we were able to multiply. I think I got one more of these. No groups, no groups, no groups. So what are you going to do, Dale? Well, I think I'm going to have to divide first, if you don't mind. So there he is. That gets us 2. Looks like next probably ought to be that multiply. Gets us 4. Now we're home. Add for 7, take away 1, 6. So order of operations, be careful, be careful. Divides can be done before multiplies, right? Subtracts can be done before adds. It depends on the order in which those processes are met when you're processing from left to right. Oh, will you look at that? That takes us to assignment 4B. More problems from your textbook. Grab some paper, sketch them on out, send me some PDFs to the Dropbox. There is also an assignment 4C that's just a combination of problems from sections 4 and 5. And then there will be an assessment for Unit 4, just kind of a really short test. So you got the rest of the work to do on Unit 4. We'll be back soon for Unit 5. See you then.